So this week you should be working on 6.3 through 6.5, due Sunday, November 5th at midnight, and working on online test 11 that's due Monday, November 6th at midnight. As always, 3 tries to get your best score. You have to get 80% or better and it'll open up. And as usual, our 3 seminars this week, Monday, Wednesday, and Sunday. All right, so 6.4. We finished off with factoring all these binomials. We have a difference of squares as a binomial, so we need to be able to recognize perfect squares. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12, 13 times 13, 14 times 14, and 15 times 15. That's about as long as or as large as I'll go with those. The other thing you need to recognize is that when you square a variable like x squared squared is x to the 4th, x cubed squared is x to the 6th. So to be a perfect square on a variable, it has to be an even power. And so I said something like, take their square roots and you recover the 2 pieces, p and 9. Subtract them and then add them. 49x squared. Pieces are 7x and 11y. Subtract them and add them. 144r squared, that comes from a 12r. 25 comes from a 5. Subtract them and add them. So you recover your 2 pieces first by taking the square roots, then you subtract them and you add them. But we also talked about what would happen if you had the sum of 2 squares instead of the difference. And there's just no way that you'll ever get this factored because there's a 0x in the middle of this. Just like there's a 0r in the middle of this one, but 60r minus 60r is 0, so it cancels out. Where with x squared plus 4, having a plus 4 there, you would have to have the same sign on your numbers, plus 2 and a plus 2, or a minus 2 and a minus 2. And those wouldn't cancel out in the middle because they're not different signs. So we say the sum of 2 squares is always prime. You don't need to factor it. And so that led us into this problem of x to the 4th minus 16. The 2 pieces are x squared and 4. So we subtract them and we add them. But as soon as we do that, we see the first factor, x squared minus 4, is a difference of squares, x minus 2 and x plus 2. And the x squared plus 4 is prime, so it stays as is. And then the last one here that we did, there was a greatest common factor in there. They're all divisible by 3 and an n. And as soon as we factored that out from our 2 terms, we were left with n to the 4th minus 81. So those are perfect squares. N to the 4th is the square of n squared. 81 is the square of 9. So we subtract those pieces and we add them. So n squared minus 9 is n minus 3, and n plus 3, and n squared plus 9. Well, that's prime. Sum of 2 squares never factors. And so those are our factors of that. Okay, so we see that difference of squares, factoring difference of squares, is pretty easy. However, we have to always remember that the sum of 2 squares never factors. It's prime. And now what we look at is the sum or difference of 2 cubes. These have a formula for both of them. So on your exam and in 5.3, we did an example like this where the x minus 2 times x squared plus 2x plus 4x times x squared is x cubed. And x times 2x is 2x squared. And x times 4 is 4x. Now we go to the negative 2. That's negative 2x squared. That's negative 4x. And that's negative 8. Our middle terms end up canceling off like the difference of squares did, but this time it ends up with the difference of cubes. So perfect placement of numbers and signs, positives and negatives, made all the middle terms cancel out. The fact that this was a negative sign here and that was a positive sign there, that's what made them all cancel out in the middle. And notice the x cubed minus 8. We need to be able to recognize perfect cubes. 1 times 1 times 1, 2 times 2 times 2 is 8. 3 cubed is 27. 4 cubed is 4 times 4, 16 times 4 is 64. 5 cubed is 125. 6 cubed is 216, but I really don't go that far. I usually leave it at 125. Okay, so look at how this worked out. The x cubed minus 8. We recover the two pieces. They're cube roots, x and 2. So your first factor is x and 2 or x minus 2. And then it says take the x that we got there and square it. Take the product of the 2 and the x and then square the 2 and get 4. So I'm going to say something like recover your two pieces and then square, product, square. And these are the formulas. We recover the two pieces, A and B, and then it goes square, product, and square. We'll worry about the signs here in just a moment. So I recover my two pieces from x cubed minus 27. It's an x and a 3. I've recovered them. Now we follow this formula. Recover them and put them in as an x minus 3. Then you square the x, take the product of the two terms, 3 and x, and then square the 3. They're all going to go like that. Recover your two pieces, square, product, square, and then the signs are determined by what we call SOAP. SOAP stands for whatever the first sign is in the difference of cubes or sum of cubes, we use that same sign, S. So if it's a plus, you use a plus. If it's a minus, you use a minus. Then you use the opposite sign. So if it's a plus, now it's a minus. If it's a minus, now it's a plus. And then the last one is always positive for AP. AP for always positive. So that spells SOAP. So as soon as you recover your two pieces and then square, product, square, you use the same sign, opposite sign of what you had there. So minus becomes a plus. And then always positive, plus. That is right, Saba. Good. X minus 3 times x squared plus 3x plus 9. So it's not the best looking answer, but it's got to be a binomial times a trinomial when we factor sum and difference of cubes. And the good news for us is that this remaining trinomial will never factor. We say the trinomial is prime. Never factors. We don't have to even consider factoring it. Okay, example 9. 27a to the 6th, that's the cube of 27 we know is 3 cubed, and a to the 6th. We need to have a cube on the outside of it, and so that would mean that would have to be an a squared. So our first piece that we're recovering is a 3a squared. Now 8 is 2 cubed, and b cubed, well, that's the cube of b. So that recovery gives us a 2b. All right, so those are our two pieces. We took the cube roots and we found our two pieces. We place them in there as they've been recovered, 3a squared and 2b. And then we come along and we square product and square. That's the pattern for the positions that the numbers and variables go into. And now we use SOAP. Same sign, positive. Opposite sign, negative. Always positive. Always positive. All right, so there's a little bit more to do on that one. We have to square the 3a squared, which is 9a to the 4th. 3 times 2 is 6. A squared b. And then 2b squared is 4b squared. And again, don't waste your time trying to factor the trinomial. That will always be prime. No matter what you try to do to factor it, you'll never get it factored. Okay, so please try practice 4 first. So you recover the two pieces. X cubed came from an X. 125 came from a 5. So we recover them and we place them in there as recovered. Then we square, product of the two, and square. We use the same sign. Plus is a plus. Opposite signs, plus is a minus. And always positive is a plus, giving us x plus 5x squared minus 5x plus 25. The remaining trinomial does not factor, so we leave it just like that. All right, the next one's a little bit harder. Try that one out. Recover your two pieces, and then square product square, and then soap. Okay, so you recover your two pieces. 8p cubed comes from a 2p, and 27q to the 6th comes from a 3q squared. So we've recovered them. We put them in their slots, 2p, 3q squared. Then we square the 2p. We take the product of the 2p and the 3q squared, and then we square the 3q squared. And now we use SOAP. Same sign, opposite sign, always positive. Two p squared is 4p squared. 2p times 3q squared is 6pq squared. And 3q squared squared is 9q to the 4. Let's see, because q to the 6th, if I wanted to cube that, it would have to be q squared because these multiply. 3 times 2 is 6. If you did 3, yeah, good job. That's a really minor mistake. If you got that far in these problems, I'd be really happy. Okay, example 10 then. We have a greatest common factor in there. I mean, as you look at it, there aren't any cubes or squares, so we have to factor something out of there. And it looks like we can take out a negative 3b. So when I do 375 divided by 3, I get 1, 2, 5b cubed plus 8. So the negative 3b is just there for the ride. And then we go binomial, trinomial. So we recover our pieces. 125b cubed is a 5b, and an 8 is a 2 cubed. So we have our recovery is 5b and 2. So we do 5b and 2. Then we square the 5b, take the product of the 5b and the 2, and then square the 2. Same sign, opposite sign, always positive. Ooh, you caught me. Good job. When I factored that negative out, there needs to be a minus sign. So we have 5b minus 2, 25b squared, 10b plus 4. All right, that's your difference in sum of cubes. Not the easiest factoring strategy, but at least it's a formula. Okay, now we will work on 6.5. And this is what we call a summary of factoring strategies or techniques. So we look at them all together since we've now covered each of our different types. So real quickly here, a couple practice problems. We've seen these before. We can factor out a 3x from the two terms, which is going to leave us with x squared minus 4. Now that we have the 3x taken out, we factor the difference of squares as x minus 2 and x plus 2. Likewise, practice 2, We factor out a 4 from those two terms, and it leaves us with x to the 4th minus 16. Now that's a difference of squares. The two terms are x squared and 4. So with the difference of squares, we add those and then we subtract those. But then we have another difference of squares there, x minus 2x plus 2. And then the sum of two squares is always prime. So that one stays as is. Okay, so those are the binomials. We also have trinomials to factor, and we also have four-termed polynomials to factor. So the steps for factoring go as follows. You want to figure out, do you have a binomial, trinomial, or a four-termed polynomial? If they're binomials, then we either have the formula for difference of squares, difference of cubes, or sum of cubes. But remember, if it's the sum of two squares, stop. This is always prime. This is what we just saw right here. If you have trinomials, you should always check if you have a perfect square first. If you have something like x squared plus 6x plus 9, you're checking that the first and the third term are perfect squares, and in the middle is twice their square roots. Then it's a perfect square. If it's not, then we do the M and N method if its coefficient is 1. If it's not, then we do grouping or trial and error. So we'll look at these things now. And if it's four terms, we always use grouping. You should always then check that your factors are completely factored and then check your work. So here we'll just go through a different kinds of factoring strategies. We've got a trinomial here. I have to admit that I forgot the most important step, and that is step 1, which is the GCF. That will make our numbers a lot smaller if I take out this GCF of 3. X squared minus 5x minus 72 divided by 3 is 2 times 3 is 6. 3 goes to 12, 4 to 24. Now, when they're trinomials, we take the coefficient of x squared, which is a, coefficient of the constant term is c, and we multiply them. In this case, it's negative 24. And it has to add to b, which is negative 5. So we run through our list of numbers until we find the two numbers whose product is negative 24 that adds to negative 5. That's negative 8 and 3. So we write that. If the coefficient's 1, then it's like magic. Those numbers just go into their slots, x minus 8 and x plus 3. If the coefficient of x squared is not 1, then we place them back in there for the negative 5x and then factor by grouping. You can factor this with the 3 in front and get an answer. However, you'll have the 3 distributed through on one of those terms, and you'll have to factor it out in the end. All right, example 2. There isn't a GCF that I can factor out to make these numbers any smaller. So I go right into the AC method. 8 times 5, which is 40. That adds to 22. So our two numbers that multiply together to give us 40 that add to 22 are 2 and 20. Now, it's not like magic anymore. I just can't place them in there. What I have to do is replace the 22x with the 2x and the 20x. From my first pair of numbers, I take out a 2x. Now we factor by grouping. 8x squared divided by 2x is 4x, and 2x divided by 2x is 1. From my second pair, I take out a 5. And that's going to leave me with 20x divided by 5 is 4x, and 5 divided by 5 is 1. So we factor out the 4x plus 1 to the right-hand side, and we're left with 2x plus 5. So we should check our factors. 2x plus 5, 4x plus 1, they have nothing in common. They have nothing, each of the terms have nothing in common, so I can check it now. 2x times 4x is 8x squared. 2x times 1 is 2x. 5 times 4 is 20x. We see where the 2x and the 20x come from now. And 5 times 1 is 5. So that's 8x squared plus 22x plus 5. All right, please try that one. Okay, so you factor out the negative 3x as a GCF. And then what we have left over with is a trinomial whose leading coefficient is not 1. So we take the AC method and we use negative 30 to get negative 1. So we have negative 6 and positive 5. So we replace the negative x with negative 6x and 5x. From the first pair, we take out a 3x. That's going to leave us with 5x minus 2. Now, we can't take anything out of 5x minus 2, so we just think of it as a 1 in front of it from the start. And so then what we have is a 5x minus 2 and a 3x plus 1. All right, so now we look at another trinomial here. And those numbers are awfully big. When I see something like that, I automatically assume there's probably something I can take out of that. And it looks like a 3. That's 25x squared. That's 30x. And that's 9. So as we run down the list of trinomials, it always says to check to see if there might be a perfect square first. And it sure looks like it might be, because 25x squared, that's the square of 5x. And 9 is the square of 3. So our two pieces are 5x and 3. So you check the middle term. The middle term is 2 times AB. So if I take 2 times 5x times 3, that's 30x. There it is. We've got a perfect square. So that would give us 3 times 5x plus 3 and 5x plus 3. Just want to check it first before I move on. And 5x times 5x, 25x squared. There's the 15 and the 15, making double that, 30. And then the 3 times 3 is 9. So it's always best to write these as the square of 5x plus 3. Okay, there's one for you. All right, so you factor out a 3 from those. P squared minus 12 PQ plus 36 Q squared. So we are on the lookout for perfect squares. We've got the P in front, 36Q squared is 6Q, and 2 times all of that would be 12PQ, which is what we have in the middle. All right, because it's a minus, we take the difference of the two, P minus 6Q quantity squared. Okay, so those are the different kinds of trinomials that we can expect. And now we look at some of our binomials that we've looked at already. All right, as it stands, we've got some cubes on our A and B, but we need to take out that 3. Let's take a negative out. That'll leave us with 8A cubed minus B cubed. So cube roots, we see that one's a 2A and one's a B. Those are our pieces. So we've recovered them. And now we square the 2A, take the product of the 2A and the B, and square the B. SOAP, same sign, opposite sign, always positive. That gives us 4A squared plus 2AB plus B squared. All right. Cubes should be pretty fresh in your mind by now, so try that one out. So the 125 is the cube of 5. The y cubed is the cube of y, and 64 is the cube of 4. So those are two pieces. We've recovered them. Now we square the 5y, take the product of the 5y and the 4, and square the 4. Same sign, soap, same sign. Opposite sign, always positive. So that gives us 25y squared plus 20y plus 16. All right, so those are our cubes. Here's another binomial. I don't see any cubes or squares in this one. Remember, with binomials, it's either squares or cubes. So we factor out the GCF, which is negative 4p. That'll leave us with p to the 4th minus 81. All right, now it's clear. Those are squares. Difference of squares. So we factor it by recovering the two pieces. Their square roots are p squared and 9. So we subtract them and we add them. P squared minus 9 is p minus 3 and p plus 3. And remember, the sum of two squares, you stop. It is always prime. Okay, so those are all of our binomials. And now we have a four-termed polynomial, which we always approach those by grouping them. When we have four terms, we group the first pair, and we factor out their GCF, which is 3x squared. That leaves us with 2x plus 3. From the second pair, we can take out a negative 3, which leaves us with 2x plus 3. Saba, that's a great idea. I tend to not do it when I have four-term polynomials, but I can tell you've been listening to me because that is really what we're supposed to do. However, I'll take out the 2x plus 3 now, and I'll be left with 3x squared minus 3. So as was pointed out, we should have factored out the 3 from the start. But that's why I keep saying check your factors now. And so if I see a 3 on both of those terms, it comes out. So I take it out now. Or you could take it out from the start. It doesn't matter. But now what I have is another difference of squares here. 3 times x minus 1 and x plus 1. That's what I tend to do a lot of, is with factor by grouping, put another difference of squares in the answer, and then you have to factor that out. Okay, so there's one for you to try. You're more than welcome to take out the GCF first, or you can take it out in the very end. All right, I like to just go ahead and factor these by grouping first and then look for GCFs in the end. So I'll take a 3x squared out. Which will leave me with 3x minus 2. From these, I factor out a negative 12, which will leave me with 3x minus 2. So we factored out the 3x minus 2, and we have 3x squared minus 12 in front. So we check that factor, 3x squared minus 12, and we take out a 3, which leaves us with x squared minus 4 and 3x minus 2. But the x squared minus 4 is x minus 2x plus 2. All right, those difference of squares have a way of coming back up in factor by grouping problems. All right, example 7. We have a binomial. Binomials are either difference of squares, difference of cubes, or sum of cubes. But before we can do anything, we have to take out the GCF. I'm going to take out a negative 4y. Negative 36 divided by negative 4 is 9. I took off the y, so there's an x squared left over. 16 divided by negative 4 is negative 4, and the y comes out. That is a difference of two squares. We recover the two pieces, 3x and 2. So we subtract those, and we add those. Example 8, binomial. We need to take out the GCF first. Looks like we can take out a 3 and an x. And when I take that off, I'm left with 2y squared plus 5x squared. That binomial that remains, it doesn't have any perfect squares. It doesn't have any perfect, well, it has some perfect squares, but the 2 and the 5 are not. There are no cubes, so there's nothing I can do with that. It's been completely factored. All right. Tell me what you get for n squared plus 2n plus 8. So you work on this one by saying the product of two numbers, that's 8, that adds to 2. And so you go through your list. 1 times 8 adds to 9. 2 times 4 is 8, but that adds to 6. There's nothing else to try. So if nothing gives us 2, then the answer is prime. Please don't say no solution. It's a kind of a use for a different scenario. That's used if you have an equation you're trying to solve, and if you can't solve it, the equation has no solution. But this is just an expression, so it's either factorable or it's prime. What about that one? Letter B, negative 25x squared minus 25. That's good. We have a negative 25 that comes out. Then you're left with x squared plus 1. And sum of two squares is prime. We don't say prime. We just rewrite it as negative 25x squared plus 1. All right, and the last one is not prime. That one will factor for you. So you take out the GCF first, 3x, which leaves you with x squared minus 4x minus 4. That way you can just look, sorry about that. That's a plus 4. We look at that as the product of two numbers that's 4 that adds to negative 4. 1 and 4, or negative 1 and negative 4 is negative 5, but negative 2 and negative 2 is negative 4. So that is 3x times x minus 2 squared, or x minus 2 times x minus 2. That's a perfect square trinomial. And so we write it as a perfect square, x minus 2 squared. All right, so that concludes 6.5.